What's up, guys? Welcome back to the Code Path to Pro. Hope y'all are doing well. It's Thursday night. American Dad's on in the background if you hear anything. I already did some problems earlier today, so I'm just gonna walk through them. I think it was 402. I just did the first three of these. Yeah. Okay. So, yeah. There we go. Um, so this is 3184. Count pairs that form a complete day. So given an integer array hours representing times in hours, return integer pairs ij where I less than j in hours. If I is hours j forms complete day is defined as a time duration that is an exact multiple of 24 hours. Okay, so right, you can do this brute force. O then squared, 2 for loops, pretty straightforward. But you'll notice that this is kind of similar to some. Whereby you can create a hash map um, and basically store kind of your missing partner, your missing pair value, and then look for that. So that's O of N solution. So that's what this looks like. So you're going to have your count, and you're going to have your good hours. That's going to be a hash map. Loop through. And what you're looking for here is if whatever hours value you're looking at, 24 minus that, mod 24, which is basically going to get, like we're not interested in anything greater than 24, right? We just want like how close are we to a multiple of 24. So if there's a pair, a good pair in our hours hash map, we can increment by that value for count, because basically what we're going to keep track of in that pair is the number of pairs we've seen for that value. So that's why we're going to increment by that count. And then here we're adding our new value. So right, 24 minus hours of I is looking for our pair. Hours of I mod 24 is just looking for that value. And we're going to see, okay, does that exist? Increment by 1 because now we found a new pair for that value, or we just add it, and then it's got one good pair. So yeah, that's that, and that's actually this problem as well. Same problem. You'll notice you're required to do the O-N solution for this one, so you can't be brute forced, I think, is the trick here. So yeah, same solution. Pretty cool. And then this one. This one was the one I stopped on. This one was tough. Honestly, I stole this solution from somebody. But this was kind of my solution. So it's a DP problem. Oh, oops. So yeah, basically it's DP because you're trying to find the max. There's a bunch of different branching paths, a bunch of different decisions you can make, and those come from, are you going to cast a spell or are you not going to cast a spell in this array? So I used top-down DP. Had a couple base cases where if you loop through the entire array, you're done. If you've seen this spot you're in already, you should. That's the caching. That's the DP part. Then you have 2 options. You can not take it, or you can take it. But yeah, this, and then you're just calling the DFS, .dp, and you're returning it. But that did not work. So this is some of the solution I found that I liked. So this is creating a counter of the spells. So kind of the trick with this problem is you can cast duplicate spells always. So basically what this is doing is creating a list of tuples where the first value in the tuple is the value of a spell, the power, and then the second value of the tuple is the count, the number of times it's seen. So then this is calling basically the same thing, top NDP. You have your memorization. Base case if it's in memory, if you've seen it, return that. If you hit the end of the set or the end of your list, return that. Otherwise, you're setting the max power to the current value. Then you get your next index, and you're looping through, and then basically looking for, can I cast this spell? Like, however many spells can I cast? And just figuring out the max from each spot. So, yeah, that one was tricky, and I haven't done the hard. Might glance it up quickly. Using NumPy. Save entry. Okay. So, cool. But, yeah, thanks for watching. That's it. Just a little recap. See you guys. Have a good night.